So just to tell you a little bit about how far we've come in 1 year, someone over lunch reminded me that last year I was doing my birds of a feather for the OpenShift Commons in a hallway alcove with about 20 people. There wasn't even a door that could close behind us. And some of you are nodding, you were in that space. It was going from that to this in less than 1 year really shows you some of the rocketing tipping point, hockey curve, sticks, graph of adoption that OpenShift and Kubernetes and all these technologies are seeing. And it's the other piece of the most pleasurable thing for me today is how wonderful these presentations have been and how I didn't have to do any of them. Joe Fernandez was saying the same thing. We were both looking at each other like kids at the candy store. I didn't have to do those slides. So this has been really amazing. And we'll do it again in Austin in December at KubeCon, and I have a funny feeling we'll do it again somewhere in between there and then. Austin is in December. So if you're interested in presenting your story as a customer or a service provider, let me know. The other thing is we're so successful, they've now given me my own mini pod in the dev zone. So for the next 2.5 days after this, I will be standing by a monitor somewhere in the dev zone by myself. So please join me, and please join the OpenShift Commons. I can walk you through the whole process and get you onboarded while I'm here. And if you bring me an espresso, it'll probably help facilitate that process. So here we go. Could I get someone in the back to shut the door? There we go. So after lunch is always problematic. I don't want any of you to fall asleep. That's why we ran out of food. So you're still hungry for more. And these guys, SBB or the Swiss Railways, didn't bring any chocolate for dessert, but they did bring their Balticloud, and I'll let them explain what that is, and I'm going to let them introduce themselves, and we're going to get kicked off for the afternoon and try and keep it on schedule. So thank you very much for bringing yourselves all the way from Switzerland.
So welcome to our speech. I'm Baltisar Oswald. My name, I'm from the SBB, and these are my colleagues, Chris Eberle from Red Hat, Reto Lehmann from SBB, and Tobias Stenzel from SBB. We would like to talk a little bit about Balticloud. That's my personal cloud. I am really proud of it. What's behind the Balticloud? It's OpenShift. And why do we need OpenShift? What are we now? Swiss Railways, I don't think that you know it, but that's the public transportation company in Switzerland, one of the biggest one. We have more or less 30K employees, 1.3K IT employees, and more or less 400 software developers. And we do a lot of software. We produce a lot of software, and well, we were really traditional. We have a traditional business, but we now have to change from a traditional business to a business that is a little bit more faster. So the time to market became an important thing for us. And why? Because Swiss Railways want to become the journey integrator in Switzerland. Means that we want to provide products for customers to give from the door to the door journey, and we will give all the services that the customer needs to go from A to B. What does it mean? Digitalization, digital transformation is one of the big things, and we saw that with the traditional IT, we weren't able to deliver the products as fast as the customer wants it. And the second part is also the culture. I mean, we were and we are a traditional enterprise with a traditional enterprise culture. So we want to move from a traditional to the digital enterprise with a digital culture, and it's not so easy to do it. And why? We started with the technology. Why? Because technology is a big enabler. And so we started with a project, a little project, to set up an environment for developers to be able to develop within hours, within minutes in production, to be able to do it as a self-service and so on. And this little project, we did it with Red Hat together, and I will give Chris Eberle the stage.
I'm from Red Hat, and I have the pleasure actually to work with these guys for approximately the last 2 years now. It's really a pleasure, and basically what we did is we really had an adoption process of OpenShift. As he said, it started very small. It was kind of, we call it U-boat project, so something which isn't really on the radar of the management, and you have some freedom in it. And what we actually did, or what they did is, first hand they said, okay, we have to follow this whole digitalization trends. We cannot do this with the technology stack we have in place right now, so the first thing they did is they defined a new technology stack with all the nice things like Spring Boot and Hazelcast and Angular, and they said, okay, this is the set of technologies we want to use to build our future, our next generation of applications. Then they thought about a packaging format for these technologies and decided, okay, containers is the thing we have to do in the future. And if you talk containers, you talk container orchestration as well. And they decided, looked at the market, decided very early that Kubernetes is the right choice to do at this point in time. Probably not because it had the most features at that point in time, but because of the community behind Kubernetes. It was very vibrant. It has still very good stakeholders in the community, and the roadmap of Kubernetes was really making their minds. In the end, they said, okay, we are not a cloud or a platform provider. We don't want to build it on our own. So they were looking on the market, what is out there, what could really help us, or what vendors could help us. And this is where we fortunately came into the game. And first things you do when you want to adopt a new technology, you do a POC. So we said, okay, we're going to do a POC, a couple of weeks. Some guys from Red Hat were on site to help them, and it was really about looking how can the technology fit into our environment, what can it help, what can OpenShift help on top of Docker and Kubernetes, so what value add can we get out of it. And then after 2 weeks, Baltisar called our sales rep and said, Mr. Brahim, unfortunately we have to stop the POC. And we were all getting white and asking why. And he said, actually, we want to do the next step already after 2 weeks. So we want to do a pilot. And the pilot in definition in terms of Swiss Railways is taking 15 applications, 15 projects, which are currently developed, move them onto OpenShift and bring them into production in the terms of 1 year. So this was the pilot scope, that we take 15 applications, put them on OpenShift, bring them into production, and harden the OpenShift platform during this journey. Then, I think 5, 6, 7 months later, it was already 45 projects who wanted to participate and run on OpenShift. And the first said, actually, we are ready, we want to go live now. So after 6 months, we had a production-ready environment, 50 applications or 50 projects actually wanting to go onto OpenShift, and this is really where we went into production. We had a lot of interactions in these times. There was still some things lacking in the product, so it was a constant close loop of iterations where we worked together to increase their operations processes as well. I mean, bringing something into operations and making it production ready isn't always easy. It is a lot of new technology, a lot of stuff in it, so this was really a challenge as well. If we look at what we have today, in terms of environment, it's 2 clusters basically, one on-premise, that's the left one, running on bare metal. They use cluster for storage on both environments, on the public cloud as well as on-premise. It's around 80 nodes, bare metal, big nodes, a lot of CPUs, 900 cores, the internal environment, around 9 terabytes of RAM, and it's stretched across two sides basically. And as well, an environment on AWS, so on public cloud. which is slightly smaller. And the idea is that you have most of the applications which interact with end users, that you run these things on public cloud, and the rest, or a lot of the other stuff, like pricing systems or these things, are running on-premise. On these two clusters, state today, or yesterday, probably today it's even more, it's around 2,000 containers which are really running and operated on these OpenShift environments. And if you look, most of them are on-premise, because there you have the big capacity, there all the heavy lifting is done, and on public cloud, it's around 10% of these containers which run there. Baltisar will talk you now through a couple of the use cases that you really see what kind of applications. It's not all just Mickey Mouse stuff, so it's really important applications as well, and he will talk you through two of the use cases.
Yeah, only a few words, because the other guys, they have a demonstration, and I think that's more interesting part is what I have to say. But overall, we have more or less 100K requests per minute. And so with this application, there's one of the most popular applications in Switzerland. 5 million downloads, a lot of people are using it. You have here scheduling when you can go from to, and you can buy tickets and so on. So we have more on peak times. We have 30K requests per minute, and that one of the most important applications for going to the goal, be the journey integrator of Switzerland. And the second one is well, the same but web. First one was mobile, and this one is a normal web application, and they launched in production for 2 weeks or 2 months ago, more or less. Here we have 50K requests per minute. Normally we have 25K requests per minute, and it was also really a success story, because they launched it, we didn't know it as operators, and everything worked. Okay. And the third one, it's this one here. We have a lot of displays. And these displays are in the future, in 2 or 3 weeks or 2 months, delivered by OpenShift, the data is delivered by OpenShift. And the decentral applications, or this one that the computers that delivers the display on the display ports are Docker containers. Not in OpenShift inside, but also Docker, delivered by satellite 6.3. And now we are ready to software engineers.
Okay, so you heard now what is running on OpenShift, what things are running on the cluster. Pretty important things. If it goes down, we have millions of people not able to use our services, and we are in all the newspapers the next day or the same day. So I'm part of the team that operates the clusters and does the engineering and upgrades. Tobias is in the same team. He will talk about the CI/CD integration and the developer experience. I will talk about some of our things we do specially. Because we heard this morning already what you guys do with OpenShift, and that's pretty similar with us. Most of the time we do the same things as you. We do HA, available clusters. We also do cluster FS, for example. So I'm going to talk about a few things that we do specially, that are invented where we are, or we did some things that help us, and we want to show you these. So the first thing is monitoring is crucial. Of course it is, but if you operate in this size, in this short time, you need to have good monitoring. So we will show you something about this. Then the most critical part are updates. And we heard about the AB deployment, rolling updates of apps, but what about OpenShift? That's, for me, the most important part. How do you upgrade the cluster without breaking it? Because this is the biggest risk. You could crash everything with just one command. And that's what we heard this just before the lunch. The federation, for example, we're very looking forward to that in case, or in terms of updates from the cluster. Then the last thing is self-service. We have, you heard it, 400 developers, the same amount of application responsible people. They all operate with OpenShift. So for us, a really big point is self-service. We can't do their requests manually because we would not do anything else. So, updates. I like the sentence. Red Hat does not like it because, because I always say, hey guys, I don't trust your playbooks. All the time you have things in there like restart all the etcds at the same time, or restart the master APIs on all the masters on the same time. And all the time I say, hey guys, we need to do in-place upgrades. This breaks our production. So what did we do? We created a little tool that we run on our development cluster, for example. We had a little problems with the display, so maybe it's a bit laggy. It's just a little tool that checks everything inside the cluster. And it creates quite a heavy load. So we can simulate our production environment on the dev cluster. It checks, for example, are the masters available? Is etcd okay? Is DNS okay? We do HTTP checks from all the levels. So we do it in the pod, on the master, on nodes. You just click here, and it starts doing the checks and should report back in more or less real time. We see I have these checks now running, so now I go to my servers, and I would do a playbook, which I don't trust. So maybe it will stop one master API. You see on the background, nothing really important happens. We are on an HA cluster. So if now the playbook would kill my second API as well, or maybe just the other command, stop it. So you just saw in the background, I got errors here, ooh, and I'm getting more errors, whatever. And down here, I'm getting a list of what errors, what did crash. So at the moment, I just broke everything. So it crashes on every point. But this little tool helps us to check if the playbooks will have an impact on our production or not. So that's just one little thing. As you saw in the presentation, it's open source. So just check it out. The second thing I talked about was the self-service. As I said, we don't want to manually handle all the requests from our projects. For example, quotas. If we began, we defined a quota set that is default, and most of the projects reach the limits very fast, so they want to increase it. And we did this manually. We logged into the server and updated it, and we didn't like this. But we don't want to give them permission to just change it to anything. So what did we do? We created a self-service portal that has certain rule sets and boundaries, but the people can still change the things by themselves, but we know what they did, when they did it, and we can add boundaries to it. Same here. I will show you a quick example, if I can get to the screen. Yeah, here it is. So this is the self-service portal. It's in German, sorry about that. You can create projects, for example. There we have additional fields for the billing, for example. So it's mandatory that you add the billing number. Otherwise, they would just create a new project and who did it, why, where do I have to do it. So I will now just say Summit 17, for example. Click on Create, and instantly on the OpenShift GUI, I will see this project. So this is used pretty often. Another use case is this quota thing. So that's the default 2 CPUs, 4 gig memory. That will be reached very fast. So we just say, I want to change my quotas. You just type in the project name, say maybe 3 and 10. Do it. And pretty much the same here immediately. You get the new values. So that's just a few use cases. We're still increasing this thing, and putting features in. We have service account creation, for example, in there. We will add monitoring setup and things like this. So my last point is the monitoring. What do we do here? We use New Relic as a SaaS solution to monitor our infrastructure, our service, for example, just what they do. Then we added a custom layer that does more or less the same checks I showed you before, just on all our clusters. And we use the VictorOps tool to do PagerDuty. That's just a little web tool that you can add calendars and teams, and it calls you if something goes wrong. If we have time in the end, we can also show it to you. Otherwise, just come to us and we can show you these things. So I will now hand over to Tobias. He will tell you about the development experience.
Okay. So we have the same setup as all other guys here. First step, we have a Jenkins or a Git repository where our developers commit their code. First step is we build and test on Jenkins and produce a jar, var, whatever, and place it into Nexus. And from then on, we have special generic jobs that are responsible for creating or creating the Docker image on OpenShift. So what we basically do is we configure a Jenkins job to trigger the OpenShift API and create image stream build config, and then instantly trigger the build itself on OpenShift to produce the image stream or Docker image. For that, we provide some generic jobs. For example, we have one for simple Spring Boot application. If you have a Spring Boot application, you can add this generic job as post-build to your existing continuous or nightly job, and you automatically will create a image stream on OpenShift that you can use to deploy. We also have other jobs, for example, to create from a custom Docker file. Yeah, basically same procedure, different stages. After the Docker build, you can use the image change trigger to deploy. There we provide different recepts. For example, the normal automatic deploy. If the image will change, you do automatic redeploy. But our projects also have or use more manual deployment strategies. For example, use manual steps in Jenkins to deploy, or use reassignment of tags of the image streams to deploy to production, for example. The other thing we provide for our developers or projects is a lot of images. First of all, we have a base image consisting of Red Hat 7.3, I think, with an OpenJDK and integration for New Relic. New Relic tool that does the monitoring. And we have a special or a dedicated team that is that provides updates and testing of all these kind of images here. So for example, we have images providing a Hazelcast cluster. We have images for Postgres, Elastic. And two main goals of these images is we want to provide technologies as a cluster, and we want to provide it monitored. So when a project wants to use a Hazelcast cluster, we have a OpenShift template where you can specify how many nodes you want to have, some other configurations. Click on create, and you instantly have a Hazelcast cluster with 5 nodes, for example. As I said before, all these technologies are also monitored. So you have completely monitoring of your cluster technologies. What we also provide with these images are functionality for backups. So we have automatic backups for maybe Postgres or Cassandra. These are all functionalities that most of the time we have to build it on a existing Docker Hub image. So we take an existing image from Docker Hub and modify it, and then our projects, our internal projects, can use that. Before we come to Q&A, here the example I talk of, it's the Hazelcast template. So you can choose if you want to have it in memory or persistent. You can select names, namespace of projects. You can choose different version of Hazelcast. For example, if you want to use 3.7 or 3.6. You can add the Hazelcast Management Center, as well as some other stuff, and click on Create, and your Hazelcast cluster is ready in about 30 seconds. How much time do we have left? 5 minutes? Okay. So I will give you a sneak preview into New Relic. New Relic is a SaaS solution for application monitoring, as well as monitoring of server infrastructure. What we see here is a APM application monitoring for vNext. That's the software that runs in the background to serve all requests coming from the mobile application on the clients when our passengers want to know where to go next. Here you see transaction times, throughput, error rates. It's really deeply integrated into your code. You can do a lot of SLAs. You can make error analytics. On the monitoring side of the OpenShift cluster, we use it to build some dashboards to provide SLAs or some metrics about these things, where our user can check the availability of the cluster. So we can provide metrics about the AJ proxies or about the Docker registry and all kind of other stuff that's interesting for our clients. What we also see here, I will say our custom checks, where we can check maybe, for example, OC-get nodes. We will get alerted if one node is out of cluster, or if etcd is not healthy anymore. Our on-call organization will be alerted and can do something. Maybe, yeah. yeah, I think that's all we have to say until now. And I would like to open for questions.
Yeah, we have time for a couple of questions if anybody has.
For your upgrades, does one cluster have all your applications, or do you split between multiple clusters and then divide traffic up on the front end?
That's what we intend to do if federation will be there. We have 2 clusters now, but they're separated. So you have apps on one and apps on the other, but you cannot move them from one to the other. So, but exactly what you described is what we tend to do in the future.
Then after you run your checks, have you ever seen a problem with an in-place upgrade?
Yes, lots of them. That's why my sentence was there. You mean if we did it then in production?
Right.
No, we were able to get to the issues in the development stage, then fix them together with Red Hat, sometimes modify the playbooks so they don't occur, and we were able to do production upgrades without issues related to the playbooks, I would say.
What type of problems did you see in the playbooks that you had to go back and fix?
Most of the time, what I described before, that they restart critical components at the same time on all the servers. That's more or less the most critical one. Other things were redeployment of certificates, for example, where something breaks because the client does not know about the new certificate on the master, for example, things like that.
One more.
Certificates? I don't know which one you mean.
So how do you generate the certificates in templates? Is that?
We don't. They're in the base image. We have the whole chain built in. So we just have imported the CH and intermediate certificate inside the Java security path, for example. And so then they trust the certificates that are on the HA proxies, for example. That's what we mean by built-in. Yeah, wildcard. Yeah.
Cool. Well, thank you very much.
Yeah.
What's the next?